All right, hello everyone. Welcome to the Marshall W. Allworth Planetarium. My name is Jessica. I am the director, and I'm not going to be your tour guide for the show tonight. I almost slipped into my regular spiel. um, but welcome to the planetarium for the second Wednesday of the month. We are always joined by the Arrowhead Astronomical Society, who will present the show for the night and then have their meeting afterwards if you're interested in staying for that. Um, Before we get into the show, if you need to leave at any time during the show, you're welcome to do so. You'll just exit through this front door here. Just, of course, be careful because it gets dark. If you need bathrooms, it's out in the main entrance to the building by the telescope. And if you have any questions throughout the show, feel free to ask. I'm assuming that's okay.
Yep, you bet.
All right, so I'm going to hand it over to our speaker for tonight, Eric Norland, who's going to be talking about the eclipse coming up in April, which is
Right.
very exciting. So, all you.
Okay, thank you, Jessica. Oh, this, by the way, is a total solar eclipse. Um, I'm Eric Norland. I'm the moderator for the Arrowhead Astronomical Society. And we meet here at the planetarium second Wednesdays of each month at 7:30 p.m. Anybody who's interested in astronomy, you're welcome to come and attend. So, big events coming up in April. And this is one of the most spectacular things to see in nature. It is awesome. It is transformation in before your eyes. It's quite an experience to see a total solar eclipse. And I'm going to just try to fill you in a little bit about the upcoming one. And I get a lot of compliments from my shirt. People say, it's out of this world. And an eclipse is something like that too. It's really just quite amazing. Now, this is the path of the April 8th, 2024 eclipse. It'll be about 8,000 miles long, starting in the Pacific, going across Mexico through North America and up into Nova Scotia, and then out into the Pacific Ocean. Now, we just had an annular eclipse in October, and that is where the moon is a little bit farther away than normal in its orbit, and so it's a little bit small to fill in covering the moon. So you get a ring, thus the annular name. And that, again, is something that is different than in a total eclipse. In a total solar eclipse, the moon and the sun match in the same size, and you'll get the darkness, which is pretty spectacular. Now, in 2017, there was a total solar eclipse that went from northwest across central America, United States, and then down into the southeast. And then this is the path of the 2024 eclipse. It'll come from the southwest, move towards the northeast. So lucky people that live right there at the center line of these two events in Carbondale, Illinois. That place has been really treated to some amazing sights. Now, the path will cut across Mexico. Durango is pretty much on the center line. Austin, Texas, Dallas, Little Rock, Arkansas, Evansville, Illinois, Indianapolis, Illinois, Cleveland, Ohio, Niagara Falls, New York, Montpelier, Fredericton, and Maine, and then on up into Nova Scotia. Here again, here's the path. And you'll notice it's a certain width, about 115 miles in diameter is the central line. Here are some of the major cities along the route. And you can see here in Texas, Austin, Texas, Waco, and Little Rock, Arkansas. Here's Carbondale, Illinois, right where the center line of the other eclipse was. Dayton, Ohio, Cleveland, Ohio, I'm planning to go right up in this area by Lake Erie, Fairport Harbor, Ohio. And then you can go up into New York and Maine and continue on from there. So the path of the total eclipse is again about 115 miles wide. And this is the path of totality, where it will get a dark effect to the sun. On either side of it, it's 80%. And then it's 60 to 70% to 80% on the next side. And Duluth is right about 70%. So it's best if you can get right on the center line. This is what you would see at 80%. A little bit of a annular kind of effect. And 60%, there's quite a crescent of the sun still not covered. So again, it's better if you can get right where the path of totality is. Now, here's an eclipse that I went to in 1979 that went across Lake Winnipeg in Manitoba, north of Winnipeg. And here is 1970s eclipse, which started and went over Florida, the eastern coast, and that was in 1970. And there is something called the Saros period, which is an 18-year period that eclipses follow this pattern. And the 2024 eclipse is 3 Saroses, or 54 years later, and a little bit to the east, and that's to the west, I'm sorry. So the older ones, the Saros period, is to the east, and they move westward. Here are many Saros periods. Here's one from 2003, 18 years later, it's 2021. Here's one from 2002, 18 years later, it's 2020. And here's one from 2006. Here's the one in 2024. And it's just this curious 18-year pattern that Saros periods follow. Now, depending on your location, you might get clouded out. The best chance for visibility is in Texas or Mexico. And you can see it's about 40% cloud coverage. Then getting into the Midwest, more like 50%. Starting to get in the upper Midwest, it's 60%. And then in the Northeast, it's 70% possibility of being clouded out. You just don't know. You could go here and it'd be clear and it'll be cloudy down here, or vice versa. It's kind of a gamble. And some people, they move around. They watch the weather and try to anticipate. Here, once again, is cloud coverage. Here's Mexico. Yes? Oh, I have a relative that lives there, and they invited me to come stay in the house. So this one, again, shows the possibilities of cloud coverage. About 40% in Texas. Middle areas are, again, 40%. 60% in here, 70. As you get farther up into Maine in that direction, greater chance of there being clouds. Now here's some average temperatures for Missouri. And it can be as high as 85 degrees or right around 43 degrees. And it can rain even 1.5 inches or so. So low temperature in Missouri can be 44 or 45. Comfortable in April. And here again is the path of the annular eclipse cutting across here, and here is the path of the April 8th eclipse. And these are the times that the eclipse will begin. And remember, this is about 115 miles across, and it's 5 minutes between each period here. So 1:30 Central Daylight Time, 1:35 in Austin, 1:40 in Waco, 1:45 in Dallas, Texas. And you can see here's where Waco is in Texas, Austin, San Antonio, Dallas. And as you continue up into the Midwest, 1:45 in Arkansas, 1:50, 1:55 in Illinois, and 2 o'clock is about like in South Ohio. So it's about 2 o'clock, 2:05, 2:10, 2:15, and then it goes a little bit later up in here. So this is the area where I'm planning to go, just a little northeast of Cleveland, about 3:15 Eastern Time, which is 2:15 Central Time. So it just gives you an idea of the time frame. It's in the early part of the afternoon. Now, a little bit of historical perspective on an eclipse. Here is modern day Turkey, which was called Lydia back about 585 BC. And here's the Persian Empire or the Median Empire. And they had at it with a good old war. You know, and it was terrible back in those days. They'd take out big swords and javelins and, you know, just do the thing. And they were going at it, and the sun started to turn dark, and it turned black. And they quit fighting and went home. Maybe we should have more total solar eclipses. So here's some of the celestial mechanics of this event. Here's the sun way over here. The moon gets between the sun and the earth. And this is called the umbral shadow. This is called the penumbral shadow. So this shadow is about 115 miles wide on the earth. Now, some of the mechanics of this event is that the moon is 400 times closer to the earth than the sun, but the sun is 400 times bigger than the moon. And so that formula works pretty well, especially when you think that the moon was created from a horrible impact. Hypothetically, it was the planet Theia that struck the Earth about 4 billion years ago. And scientists have even detected lumps in the Earth, which they think could be Theia, parts of Theia. So that debris was spread around the Earth, and anything that is larger than 300 miles in circumference tends to turn into a sphere in space. And this orbited the Earth for quite a while, and then the debris consolidated into a 2,000-mile sphere, the moon. So here again, here's the sun, here's the moon in between the Earth and the sun, and here's the umbral shadow and the penumbral shadow. Here you can see the moon, the umbral shadow, and that 115-mile wide dot. So just a little bit of trivia. The last solar eclipse will be in about 563 million years. After that, the moon, which moves about 1.5 inches away from Earth every year, will be too far away for it to happen again. So enjoy this. You know, it's a long time We've got to see some eclipses, but then it's done. So, just hang in there, and that's quite a while to wait. But, you know, this kind of event for celestial viewers is quite exciting. And you will see that it's an amazing thing to experience. It's probably one of nature's greatest experiences that you can have. And back in the old Bible days, they talk about in Luke at the crucifixion, it was about noon, and darkness came over the land as the sun's light failed for 3 hours because of a solar eclipse. Read the footnotes, and it'll say a solar eclipse in old Bibles. New Bibles don't say that. And at the second coming, the sun will become black as sackcloth and the moon like blood. Again, kind of a description of a total solar eclipse and a lunar eclipse, which are the most amazing things to see in nature. By the way, you can't have a solar eclipse on Passover. Jesus was crucified on Passover because Passover is always at the first full moon after the vernal equinox. So there's some things to discover. Here's that dot, 115 miles wide. There it is from space, the eclipse path. Now here's the first eclipse photo from 1851. Notice the corona, kind of bland, not much happening there, but there's some good Bailey beads. But that's an amazing photo from way back. The partial phases of an eclipse last about an hour and 20 minutes. The duration of totality will be up to 4 minutes and 27 seconds, almost double that of the eclipse of August 21st, 2017. One of the things to keep your eye out for during an eclipse, of course, you have to wear protection until totality. Then you can remove your protective glasses, and I'll show those in a minute. But you can see the corona. And this is the sun's outer atmosphere, kind of a plasma area. And it's hotter than the sun. And it comes in all variety of shapes and sizes. They vary quite a bit, the coronas. And here is kind of like wind-blown hair. And the solar wind creates some of these kinds of effect. Here's one that looks more like a flower, like a petal of a flower. And again, you can see some prominences and Bailey's beads poking through. Bailey's beads are sunlight passing through lunar valleys between mountain ranges. And so that's pretty cool that you get this kind of effect. And here you can see some diamond ring effect and some Bailey's beads. Here's the corona, a solar prominence, more Bailey's beads. Here's a diamond ring effect. And you can really see it does kind of look like a diamond ring. So the eclipse starts about 1:59 p.m. Totality 3:13 p.m. Eastern Time. Totality ends 3:17, so totality isn't very long, about 4 minutes. And there's the diamond ring effect. These are some of the times in Texas, and it says it's about noon is when the eclipse just starts to begin. Totality isn't until about 1:30. Just so you have an idea what time you want to be there in Texas. And you've got about 4 minutes of eclipse time to experience. Now, it's really important to wear these sunglasses these solar filters when you're looking at an eclipse. You do not want to look at the eclipse without them. You will hurt your eyes permanently. And it's very important to not to go without this. They're readily available. They'll be offered to the public. So make sure you get them. And here's the center line of the 2017 eclipse and the 2024 Carbondale, Illinois. I did go to the 1979 total solar eclipse in Montana. And here's the path right here. Went right across Lake Winnipeg and up over Hudson Bay. And the local community had made a nice ice sculpture. That was me, and this was my buddy. And this was, kind of a big deal for this little town of Riverton, about 70 miles north of Winnipeg. I had my little homemade 4.25-inch telescope and could look at the sun with a solar filter, and then at totality could remove it, but it had to be very careful. My buddy looking through the same telescope, that is. We would just use a 35mm camera to take pictures right through the eyepiece. Now, as the eclipse totality time approaches, you can see this darkness coming from the southwest. And it's kind of scary. It's like the wind picks up a little bit. It gets dark. You can just see the dark spot moving towards you. And the sun starts to go dim. And you can feel this darkness coming in quick. And stars start to pop out, like here, right here's one. There's another one in here somewhere. It's unlike a day you've ever seen in your life. What is going on? You can understand why long ago it was so mysterious. Here's that umbral shadow, umbral shadow, that is, from the eclipse path moving towards you. And it, I noticed roosters started crowing, and it got cold. Street lights come on. And then the sun turns dark. Now, I might be incorrect, but I thought I could almost tell this was moving a little bit. The corona was moving, but it could have just been, playing little tricks on me. But it is just so mysterious an event to experience. And here actually were those stars. Here's the eclipsed sun right here, but it was Mars and Mercury. And then there's some stars of Aquarius. Here's the man's head. The water jar is in here. And here's some stars of Capricorn. And then it's, you're able to take photos of the sun and see the corona. And again, it's like wind-blown hair moving. Quite an amazing sight to see. It's so unusual. Your perspective of a day-to-day sun that you normally see and take for granted has been shook. And you're kind of put into a quandary. But it's great to experience that. There's the corona again, and maybe there's a few Bailey beads on that. On the original photos, I could see stars. I don't really quite see them here. But there were a few stars up in this region. And now the umbral shadow is starting to move to the northeast. It's starting to leave. It's lightening up. And you have to wear your glasses again when the totality is finished. And be certain you have these. They can save your eyesight. You don't want to goof around. You can use number 14 welding glasses, but it's recommended to use the eclipse glasses. They have a little better filter. Now, in 1919, this man did an experiment to test Einstein's theory of relativity. And his name was Arthur Eddington. And what he did was he brought his telescopes to watch an eclipse in Africa and to see if stars were out of position during the eclipse. Because the sun distorts space and time. And this is what Einstein predicted. And this is the actual photo Eddington took. You can see a prominence, and here are some stars. And he was right. Einstein was correct that these stars were in a different position. And it's true that the sun distorts space-time. These are some of the instruments Eddington brought. He had to transport everything and be ready to go. And that's something, if you go to an eclipse, have your camera ready, have your telescope ready, have all your equipment set up and ready to go. Test it out. Be prepared. It doesn't last long. This one is 4 minutes, but that time just flies by. So here and again is the distortion of space caused by the sun, and the star will appear in a different position than it actually is, but the sun will cause that kind of an effect. And it's something that one of our members is actually going to be testing at this coming eclipse. He's going to try his own Eddington test. So here's the sun right here at the April 8th, 2024 event. You will be able to see Mercury and Venus, Saturn, Mars, and there is a comet that might be visible, and Jupiter and Uranus. So quite a variety of planets to see, and they will pop out, and you'll get to see them during the daytime, and it's really quite a treat. Here once again, here's the eclipse, Jupiter, Venus, Saturn. They're the brightest planets. You'll be able to see them. Oh, just to show again that the sun distorts the position of a star. And something that Einstein predicted, and it was tested. So now when you look at the sun, just remember, that's the same sun the dinosaurs saw. Of course, they didn't really have the intelligence to understand what an eclipse was, but they would have seen it, and it's been around for a long time. Now, here's another thing you can keep an eye out for: sun shadows. Leaves from trees will cause a lensing effect and cast these shadows up on the sides of buildings or sidewalks, and they're like little eclipses. So look around, listen to farm animals, dogs bark, streetlights come on, and you can bring a colander along and make little eclipse patterns with that. You can experiment. Anything with dots will make a lens-like effect. And that's really fun to notice. I've seen that a few times at other eclipses. There's some more you can see the tree leaves up on this shadow area, and then in between will be the lensing effect of shadows. So animals can sense when a solar eclipse is happening. Cicadas stop singing, bees get restless, squirrels run around. So it kind of affects them too. And keep an eye out. It's pretty cool. There's new discoveries to be made. Now, lunar eclipses can happen 3 times a year, but a solar eclipse is kind of rare, like yearly. And Solar eclipses are more select in a certain area. A lunar eclipse can be a whole country. Now here's a drawing made in 1860 of a total solar eclipse. And scientists have looked at this and thought, this could be a coronal mass ejection, a drawing of one from a long time ago. I just thought this was pretty cool. The average speed of the moon's shadow as it crosses the US is nearly 1,700 miles per hour, 3 times faster than a supersonic jet plane. So remember, wear your glasses, keep an eye out for tree shadows, use your welding glass, or make a pinhole camera, and witness one of the most spectacular events to be seen. This is our astronomy club, and I thank you very much for your patience. Have a good evening. Thank you. Any questions? How many are thinking about going to the eclipse? Oh, a few. Well, I hope you can make it.
Well, for anyone who's not planning on traveling for the eclipse, we will be doing a viewing here. That day, we'll have our solar telescopes out in front of the building. And if we don't have good weather, we'll have a stream in here. So we'll be doing that. I believe it's going to be like 12:30 to 3:30. But you can check our website and social media. I'll be getting the details on that up very soon. So yeah, if you're not traveling, you can come join us
Great.
for a viewing of the eclipse in April.
Drive safe, everybody, and thank you for coming.